the session today about hobby and how apply my professional skill on my hobby. So the hobby is actually, it's called fuse beads, which we can see here. It's kind of, we have a board and we have kind of plastic beads, and we put every different color. We put different color on the board to create a beautiful shape or image or whatever things. You will see examples later. And then just a brief for myself. I'm an architecture designer, and also I'm a software developer. So I have a dual master degree in both architecture and computational science. And so my main focus area is architecture vs computation. So that's how I design. So I use computational methods in architecture design or to any other design methods. Instead of draw anything manually, I use algorithm or parametric control to control a design instead of draw a manual design. That's my focus. And now what you can see here is all the beautiful images all from the single beads. So anything you can see in your life, either it's a 2D print or 3D modeling or anything, because everything in our world, we can simplify them as pixel or voxel. So if it's a pixel, then we can use this kind of beads to create a pixel artwork. Or if it's a voxel, then we can first create a pixel piece and we combine them together into a voxel model. So that's how the fuse beads work as a kind of tool for a pixel art. And also, if what you see now is kind of even a real person image, we can convert it into a fuse beads drawing, and then follow this drawing. We can create a kind of it's similar to printed art, but it's pixelized because there's some limited for a bead. There's a kind of 2.6 millimeter limitation, and then we have to, if we want more detail, we have to make it bigger. It's not like the print that you can make very single detail, so you have to simplify the image or you have to enlarge the image to get the detail. But there's some problem. If you see this image, it really do it, you can see it might doesn't really the color is different. And then there's multiple reasons, because we have different brand for the beads. Although they are following the same color level, but different brands, they have different color deviations. Maybe one color is more bright and one color is more dark. And then this result, the first image, the highlight area on the face, it's too bright. But actually on the drawing, it's not that bright. And then the second one, there are more darker area on the face, but actually on the drawing, it's a neutral area, neutral color. But all this problem are about the brand's control. This is not what we're going to talk about today, but what we are going to talk today is, if we look at the third image, it's more or less similar to the drawing, but you can see in real life, we can see more dark dots at the edges, and also we can see more pixels. It's more it's not smooth enough as an image. There are a lot of noise. So we are going to share today, it's how we're trying to get a pixel art with computational method or computational sync from if we convert it directly, anyone can convert with the app, maybe we can get the left-hand side result. It's there's a lot of colors, but there's a lot of noise, and then the color might be a little bit different from what we expect. But in today we are to share a workflow that we can get the right-hand side method, which is more smooth, and also it's easier to create the real artwork in physically. So if we can look at here, first we can think what makes the difference. So if we can look at the information, the middle one, it's original image. We can see the RGB color. It's more or less a bit shift to the left, and the right hand side, the bright area is a bit less, or it's nothing this area. There's nothing. And then, for the left hand side, you can see why there's a straight line. The reason the straight line happens is because we have limited color for the bits. There are only 221 color for the bits. So we have limited color instead of the like thousands of color like here. Because we have limited color, so when the app converts the color, they are trying to find the closest colors. For example, all the colors here, they are trying to convert the colors here. So that's why if you look at like similarly, also they have no color here, and then they are trying to have this. But the problem is, although they do try to find the closest color, but the color is very limited. Maybe, for example, you want a dark gray and then light gray and then white. But in fact, they only have dark gray and white. So it's a big jump. So that's why this big jump results in this kind of unsmooth area on the face. But if we look at the right-hand side, all the images, they are shifted a little bit to the right, and then they are less at the corner. But generally, the shape is like slightly keep the same shape, but just the color is shifted to the right. And also, still we are limited to the color, but we can see we have more like colors to keep them more or less closer to the original color. Although obviously it's bright, like here, obviously it's bright, but the general relationship between color and color, they keep the same. So that's the main logic to convert the color. So the reason why we shift the color to the right-hand side, there's a specific reason, which is this. So the color we show here, it's the whole color that the beads have. So for now, that every brand, they have the same color level, which is 221 color. And then if we look at the information, so we can see that most of the colors, they are on the right-hand side and less color on the left-hand side. So that's why we are trying to shift the color from left to right. So in this case, we can utilize more colors physically. And then when we analyze the color, we can see this. So this is the color cube. You might have already seen somewhere else. Like, so there are more different ways to represent the color, like RGB, which is the most common way, and HSV, which we represent it as a hue, saturation, and value. And then the LAB, which is illuminate, and AB is more like shift from like cyan to red or yellow to yellow to blue. It's kind of color shift. So if we look at the color cube, this is the whole color cube. But when we put the fused bead color, we can see it's limited. Especially we can see in the right-hand side, LAB, it's more towards the light area, and there's less on the dark area. And if we look at RGB, it's okayish, like red, green, blue, both of them, they have some, but we can see most of the bright color are towards the yellow color, like yellow part. And if we look at the middle one, like HSV, it's like the lower saturation, it's more like there's some low saturation color, but most of them are like towards like this area. It's more bright instead of low saturation. So that's why we have to analyze the color. We compare the color. We know where they are. We know where they are in the space. So we are trying to push our image to those areas. So that's the thought to convert the color. And then there are more ways we can utilize the color cube. For example, the start point is always black. The end point is always white. And then if we connect a line in the space and then we find the closest point, we can find this, which is gradient color. So anything we just draw a line in the space, and then we set up a start point and the end point, and we found everything along this line. Then we get a smooth color gradient. And then the first one, it's like maybe the distance is closer, it's less than 10, then it's this kind of thing. Is if we make the distance larger, which like this area, we get more color, and the color will be more vibrant. And then if we get more like even further like in the space, we can have like more vibrant color. So that's that's how we utilize the color cube to compare in the space. And then that last image, we saw a straight line, and now we just saw a curved line. So in the curved line, we can draw any curve in the space, but still we can get a gradient color. Like as long as we follow the curved line from the start to the end, anything on the line, we get a gradient. And then, like, for example, we want a blue one, so I start blue, or start black and white and middle, let's say blue, and then we get a gradient blue. So that's how we find gradient color in the space. But there's one specific situation, which is the last image. So the start is here, it's black, white. But the problem is we draw this line, but there's nothing here. There's nothing here, and then now we find something yellow here and nothing again. So if we look at this gradient color, black, yes. White, yes, but black jump to yellow, then there's a huge difference. Although when we put them together, they looks like a gradient color because this part is gradient. But from the first two parts, the black to the yellow, because there's a huge gap, we don't have a smooth gradient. So that's why in the space we see it like maybe it's not a great gradient color. So that's why we have to try to find another way. Let's say maybe this way to find a gradient to the yellow, or this way to find a gradient into the yellow. So maybe we can have a more complex curve, which is like this. So for example, we can draw more complex curve in the space. So we want something from the black to the white, but we want them, and we also want the orange or yellow to include it. So we are trying to find this curve to become a gradient color. So it's similar. So any line, any curve, like either it's simple or complex, as long as you can draw a curve in the space, and then you will find the like suitable gradient color, follow your color zone. And also because if you remember, all these color are limited to 221. That's our limitation. So that's why we have to find the best curve in the space to like within these 200 colors to find our best match. So that's the sort to find the best color. And now we look at back. So when we look at this image, when we compare those two images, as we said, there's nothing at the right-hand side, but there's a lot of at the right-hand side. So that's why if we shift this thing to the right-hand side, then we can get more color here. So that's the core reason we want to shift the color from the left to the right-hand side, because we have limited color. We want our target color in the space to more closer to our 200 color sets. So that's the inner logic to adjust this image to match them. And then, so this is our adjustment. So first we have original color, and then we shift them to the right-hand side, which is like this. We keep the similar shape, like this kind of a steep shape. And then finally we do the index color, which is this color is limited to 200, but still like if you can see it, we can still have a lot of like color relationship, like the dark area and the bright area. We keep the image structures the same, but we just shift the color to match the physical color. But now this is not the end. If we can look at this image, the right-hand side image, there's a lot of noise. Like here, a lot of small little dots. These little dots, although as image, it doesn't really matter. But the thing is, we have to make it physically. We have to put every single base on this board. We have like, if we keep those little noise, then we have to, we put one dot and we have to change the color. We put another dot and change the color, which is very noisy. It's kind of reducing our like affect our time, and also the result might be tricky because some of the brands two color, if we use two color together, and then also on image they look similar, like they are very close to each other. It's like a super nice gradient, but because of the brand, maybe the color become a big jump in physically. So the best way is to we reduce the color, like we reduce the noise. We make all the edges smooth. So that's our target to improve it. And how we do it? So if we look at this, because it's a pixel art, so the way we handle pixel, there are three different ways we handle pixel. Like for the first one is minimum, which means if we have 4 pixels together, we analyze which one is the minimum value. So it's a black one. Then we take the black as a final result. If it's a medium, then it's which one happens the most, which is a gray one. So we get the gray color. If it's a maximum, then which one is a maximum? Then it's a white color. So that's why we have this three color. But these three results, we can say like this one, especially the eye area, it's darker. The medium one, it's a bit tricky because we lose this kind of details. And then if we look at the maximum one, all the highlight kept. And there are like some highlight in your eyes is kept, but the dark area lost. So how can we combine them together? That's the next question. So that's how we trying to analyze the images again, which is high pass. High pass means if we analyze an image, we analyze from the middle. So what's the difference from the side to the middle? Because they are the same. So it's 0, 0, 0, 0, 0, all 0. Okay, then it will become the same color. So that's the middle one. So there's why there's a lot of gray area, because those area, they have no difference with the neighbors. But if we look at the darker area, because like the eye line, because eye line is always darker than other area. So the middle one is black, and then when we compare to the right hand side one, because it's more dark, it's black. So that's why like I look at the neighbor, it's white. Let's say it's 5 times difference or it's 4 times difference, and then we sum up them, then we get the result. Or it's dark. So this area it's more dark. It's darker than any other area. So that's why we get this result. And then also the same as the bright area, we compare to the neighbor because it's white, so it's brighter than others. So we sum up, like let's say it's 5 or 4 or 6 or whatever numbers around, and then we sum them up, and then we get, it's brighter than others. So we get these 3 images, which is darker area and the neutral area, and then the light area. And then now, because we got how we combine them. So if we combine the darker area with the minimum, so we get the dark detail. If we get the light area with the maximum, then we get a highlight on the face. So as long as we combine them together, we get the detail. And then with the detail and the medium, we join them together so we can have a smooth final shape. Like you can see here, this one, maybe this one is not clear enough, but once we make it index color, which is limited to 200 color, then we can see this edge area, it's smoother than others. And also we can see less noise, like there's no dots here. So it's when we do the art physically, we just do, we do this color area first, and then I can change to another bead, and then we do another color area again. We change to another bead. So it's like improve our workflow, but just with color adjustment. That's how the thing works. The tricky thing is here, all the method, it's logically work. But in, let's say, normally we do Photoshop with color adjustment, but in Photoshop, we cannot do, like, for example, we can do adjustment, we can do selective color, we can do like hue, shift, but how can we see the final index color? Because in Photoshop, they have their inner mathematical logic to calculate how the color changes. But the tricky thing is they have a specific mode which called index color. You cannot use any of adjustment layer. So that's the difficult part. So what we want to do is we want to see the real-time result, but we have to work it around because Photoshop, for now, like Photoshop, they do not provide index color with adjustment layer. So that's why this happens. So there's one adjustment layer called color lookup, which they take 3D lot. 3D lot is kind of, if you do photograph or those kinds of specific filter, then you can have a lot of different color lot because the way the lot work is just they give you a color cube and then they tell you any area in the color cube, it should become which color. So if this is kind of 3D, like for example, like RGB, we have 255, and then every 255, then we have a table to look up which color we want. For example, we input dark gray, but actually we don't have dark gray. We only have light gray, so we will find light gray in this table. So that's color lookup. So how it works. And then what we have to do now is we have to make our manual color lookup because it's not provided in any of the built-in function. So the left-hand side, it's a simple code that you don't have to really understand the code. If you want to use it, you can just download whatever others share the 200 colors, or you can ask AI to do the code for you or whatever. So the left-hand side is how we create our own code, but the right-hand side is the result. The result is, you can see this area, they are the same. And then the following area, same, because we only have 2, 2, 1. So that's why we like, let's say 10 color, they become 1 color. And then another 10 color become 1 color. So that's the inner logic to the 3D lot, how it works behind the adjustment layer, because we have to use it as a real-time preview when we adjust the color. So that's how we apply the code as an adjustment layer. And then finally, we can get our final drawing. This drawing, you might, if you are architect or you are production engineering, or you might be familiar with this part. We are not going to be very super detailed in this part because it's called Rhino and Grasshopper. It's kind of parametric design. And then that's how that's my workflow. The reason why I do it, I will explain later. But any drawings like this left-hand side, it's our final drawing. If we put our final adjusted image into any of the app, then it will convert the image to this kind of formatted drawings. So we can take this formatted drawings to do our pixel art. Because if we zoom in here, they are all numbers, like color labels. So all the color labels, they are it's labeled on the beads. So we just find the correct beads and we put it on the board, then we can do the art. And also the board, it's because if you can see there's lines on the board, it's like 10 by 10. And then also on the drawings, there are 10 by 10 thick lines. So that's how we apply the color to the drawing. And then from the drawing, we do the pixel art. And then so now the reason why we are trying to do it, I am trying to do it manually instead of just using software. It's because this. So if we look at the left-hand side, maybe we have already mentioned about it because different brands have different color, and they might be, maybe on the drawing you see it as a bright color, but in real it's a very dark color. And then if we just use an app, then it's tricky because we cannot change. We have to fix to the whatever the app provides us. But if we do it manually, because we write it in our workflow, I can change the label manually. Let's say what I did from the left-hand side to the right-hand side is just I changed the label. I didn't change the drawing at all. I just changed all the text on the drawing from one color label to another color label instead of change the color behind it. But if we do it with any app or software, we have to change the color. That's annoying part because we cannot control what color the software provides us. So that's why I prefer to do it manually in my method. So that's the general way we try to do it. So this is what the poster preview of our next week workshop. So like this kind of thing, it's how the pixel art works together. And also we can do it like a 3D cube or flat one. So this is how it works. And now until now, it's a kind of color adjustment session. And from now on, we are going to move to another thing, which is pattern. So all these things you see here, they are patterns that we created with a few speeds. But how can we create our own pattern with kind of algorithm sync? algorithm thing, you might see it like a very boring thing. It's like black and white, which is binary, like 1, 0, 1, 0, 1, 0, keep 1, 0. But if we utilize it, for example, if we just set up a logic, the logic is if the first line is black, then the second line is black. And then if the first line is white, white, black, then it's black. So we only set up this kind of logic, and then we allow them to run by themselves. Then they will follow the logic, like the first line, it's this color, then the second line, it's like like this color. So it's white, white, then black, which is black. So they're trying to find all the logic come like back and forth to find this shape. This is simple. But if we try to change it, which only change one here, we only change one logic here, then we got a totally different result. And if we change two, then we got another different one. Here are like, for now, like until here, it's iteration 4. If we got more iterations, like 16, 32, or 46, 64, like the more result it is, then the more complex pattern we get. And also we get different patterns from different logic. I'm going to show a video here, which is like, I will speed it up. So the left-hand side, it's a logic, and then anything we see here, the resulting different. Hmm?
It's not true.
Oh,
It's it can. How can we share both screens?
Should I send this video later? Or?
Yeah. We can.
Or you can take your camera to here. To there. Okay. So like you can see the left-hand side corner, it's a change for the logic, but the result will be super different. There's a lot of funny result, but you won't imagine it by your hand because it's just come from a single logic. So that's how the algorithm work to create patterns. Okay, I just quickly like different patterns like these. Okay. So that's how the like simple logic to create different patterns. And then even we can have more different patterns like this. Like as the longer we run the iterations, then the different patterns we will get, and they might be repeated. Like this one, it looks repeated, but this one, there's a lot of triangle at the top, and then they become less, and then at the end it becomes single linear shape. So that's how we create the pattern from a single logic. And like this one is also similarly, we have different start points, or we have like all the images like what we see here, they start from the middle, and then here we can see it start from the right hand side, and we get another different pattern. So that's how the inner logic works from the single logic to the pattern. And then if we not limit it to a triangle shape, we just create let's say a square, then we can see, oh, maybe we can create this kind of pattern. They just from whatever, like edges from a square, and then it's not like 2 lines, or maybe it's like three lines, or it's a diamond shape, and then we got this kind of result. So we just set up the logic. We are not going to set up the final result. We set up the logic and then allow it to run. We don't know how the result will be, but we will see it. And once we got the ideal result, we just click stop, and we got a pattern. So that's how the algorithm work to create patterns. And so all the images from here is from this book. It's kind of science book. If you're interested, you can have a look. There's a lot of examples to how to the cellular automata, like it's called CA, how it works to create this kind of interesting shape just from a single logic. And then there's another application for this logic, which is a Conway's game of life. So you might see this game somewhere else. So it's very simple. So you have this kind of grid, and then you draw some random pixels on the screen and allow it to run. And it will see, for example, the left-hand side, because it doesn't run anymore. The reason why, because they reach the limitation. It died because the right hand, let's say, the right hand side it's black. There's nothing allow them to run, but this one it's keep running. The reason why it keep running, it's because they follow this kind of logic. So, for example, like each cell with one or no neighbor, so it's possibly it will die. Or if it's like populated, like surrounded by other three cells, then it will generate another cell. So it's all about logic. So you just set up the logic and allow it to run. And then there are some examples here. So it's somebody trying to find interesting patterns from this game. They just set up, like this is a firewall, and then they just set up whatever pattern or whatever start point, and then they are trying to find the interesting result. And then once they find the interesting result, they say, okay, this is what I want. Or like this one is very complex. If you see it, you might look like a kind of small animal or whatever, those kind of abstract things, but it's all from the logic. So that's how the algorithm works. So, but because it's pixel, so we can apply it. So here, what we are trying to say here is from a random inner logic, we can apply a pixel because it's simple and easy to become a whatever pattern shape. And then after that, we take this pixel art to create our fuse bit, then it becomes your own art. But you might don't know how to do it from the start because you have to run the generations. You have to run the iterations as long as you run it. And once you stop it and you love it, and then you do it, you take it as your own art. That's how the pixel art works. And then like those kind of art, it's okay. Maybe you just enjoy it, but the different thing is you don't want, but you get it. So that's the difference from the manual drawing art with the. So today's sharing, it's all about it. And if you are interested in the fuse, which we will have another workshop next week, the same time. But from afternoon, we'll play with beads so we can create our own work. Yeah.
Thank you. Thank you. Brilliant. And actually we can gather around and take a look at those beads and the board and materials that you kindly brought us. So and some people online, and we're gonna play.
What we got here is we have a board which is like this limited size, but we have a larger board. Normally this one is what we will provide in our workshop because it's if you see it looks small, but actually there's like because it's 50 by 50, so which is 2,500 beads, which is actually a lot. And then these are all the beads. I only took a little example. So like they are all age level because I didn't take any other colors. But all these colors is like this. Normally we take okay. We are going to take this color scheme to this. So we are and then we just take the thing for this thing is this one. We just. But it's very difficult for a starter to use any other method. What we do is we take this bead and then we put it on the dots. We put it on the dots. That's how we created it. It takes a long time, but when you do it, you don't. Personally, I love it because I don't have to think about any lessons. It's just kind of time. And then we have this because if we do this, it's very difficult. We have to, if we do a complex shape, then it's okay, 1 second, another second, which is very slow. So that's why there's people's improved it. So we have this kind of needle. The way we use needle, we have this kind of tool. This is what I 3D printed, but actually you can buy it. I just 3D printed anyway. If we take it and then put it in and shake it. Oh, sorry. And then we got this kind of linear, and then we just then we got a lot of things like once. So what we do, it's like here, like this way. I do it very randomly, so it's a bit messy. But if we do it properly, then it's proper arranged. So like there are people trying to create those kind of tools to improve the process. Like this one is again similarly, but you put it in and then you do like this kind of way. Yeah. So there are different ways that like people trying to create.
And it has to be that cute.
Yeah. Oh, if you, I didn't bring the cute one, but like this area because it's 3D printed. Like somebody create like Hello Kitty or whatever shape here just to make it. When you use the tool, it looks nicer. So that's a funny part. And also, even if you use this kind of shape, because this one, for beginners, it's a bit difficult because you have to handle like you have to control your hand very carefully. Otherwise, it will be slip. So they create this kind of thing. So the thing is, so it's again you have to shake it, but what you can do is two together and then put, and two together and then put. So it's faster than you take it out of the bag and put out of bag and put. It's just a little bit ways to improve your workflow. So that's how the things work. That's the tools that we will use in our like. Let's say we can take it as a toy, but you can create any other like art you want. That's a way.
I still have a question.
Yeah.
Why the board is like this kind of positive pose, and we put the tube on top of the pole, but instead, like in circuit boards, we basically have the little kind of metal balls into little curves and then into little dents, and then you can melt them. But why
okay, so the reason is so if you trying to raise one question is actually, do you know how to, after I create, let's say I create a rectangle, but I want to
you can change it.
And also after I create this rectangle, I have to fix it because otherwise it's just something that whatever messy. So the way I fixed it is I have to use iron to mail it. So because I have to mail it, we need some space. So that's why if we look at the section of this beads, it's taller than the little yes. Yeah. So when you mail it, it will only cover a little bit and then it will connect together. Yes. And also because actually the mail part is another important process because normally if you just iron it, after it melts, it's a flat piece. It's like whatever plastic, like this plastic, whatever plastic, it's flattened. But the tricky thing is, I'm sorry, I didn't bring my sample. But for example, if this is a textile, we put it here, and then we put this, and then we put whatever, like after we iron it, because it melts, and then the backhand side, because it's melt too, so it will take this texture. So that's why we have different, let's say, finish. Either it's kind of textile finish, or it's like a like flattened finish, or it's like shiny little piece. So whatever you put it at the back, it will take that texture. So that's the finish. You can play with the finish, like different finishes. Yeah,
it's quite interesting.
Once you make this pattern or any picture, you just do it manually.
Yes.
Then by your eyes, how do you know where is this color? Where is this
so it's if give me a second. It's this one. If you look at this here, you see. So this square. This big is 10 by 10. So this big one is 10 by 10. Okay. So everything I just know where to start. It's 10 by 10, and then what color it is H17. So I put that way. Wow. Yeah. So it's kind of time consuming. Yeah, but and also if you look at here, because so we will always have a grid to know how many numbers we need. Like this one. Yeah, this one is to 100 And 4, it's a large board, but this one is like 52. So like you can see this little bit. And at the back, we have a little bit. Yeah, you can combine together. So that's how it's work. If we make a large or small.
Yeah. So delicate.
But I think the point is it has to be time consuming and energy consuming.
Yeah.
So it became a meditative process that
Yeah, sure.
like doing juggling or stuff like
Yeah.
really enjoy the
Mandala.
Yeah, that's true. And it's sort of self-curing in this process.
Yeah.
Especially when you have some speech at the background playing some Derrida in students.
Yeah. And also you might like how to say it kind of change yourself because it's very small, and then you have to be very careful. You are not mixing color, like mixing this color with another color, or you're drop it. Oh, it's a mess. Then somebody like because somebody there's a lot of people after they do like this huge image and suddenly it become a mess, and then they have to start again. So that's this kind of thing. It's kind of story behind that. Kind of train yourself.
Two parts of training. One is steady hand or sharp eyes as well, and then you're like how you deal with frustration.
well, it might be different from people, but people like you. Maybe you can try it once, and you know if you like it or not, or you take it as a hobby or long term. So it's kind of just an experience.
I went and find a job in surgery and become a surgeon because I'm steady.
Yeah, that's a kind of story.
How long does it take normally when you finish?
If for me actually I'm fast. Actually, I would say I am fast. So if this whole bit this roughly 2 hours.
2 hours for it. Oh.
Yeah, like full bit. But normally if I have some examples I can show, which is like maybe okay, this one, this little one is just one square, which has like 10 minutes, and then this one is like this shape. I did like 1 hour roughly, and then those are just combination of the small one. It's like six faces, so it's roughly, let's say 1 hour roughly, because we have to do it somehow. Just they like people are trying to improve the process. Like for example, we have different tools, and then we also have different drawings, which means if we look at these drawings, like these drawings, it's a full drawing. It's when we look at it, it's very difficult. We have to recognize this color and this color, they're different, and this color happens there and there and there. So it's a bit difficult. But what we can do is we can only highlight this color and put all the color gray out. And then we know, okay, we only focus on this color this time, and then another color, another page, only highlight one color. So that's how we improve the process. So there's a lot of like different ways to improve, but still we need some like process to do it.
So you can only highlight it on your screen, like on the app, and then but you need to find all those numbers like this. Yes and no. So yes, it's normally we only have this kind of simple board, but now somebody create a electric board which you can highlight on the board. So there's kind of backlights on the board, and then you know which color it is, and you highlight it. Yeah, so there's a lot of kind of new creations from just to improve the process.
So are there many manufacturers who make these board and beads?
Yes.
Do they make other color, like a broader spectrum of colors?
Yeah, like this one, I bought it very simple. Like there are yellow, whatever, like beautiful colors or beautiful patterns on the board. Because what we need is actually lines and so whatever at background, we doesn't really.
But like 2 to 1, standard. Do they make like 2,000 ones?
Okay, so the 2 to 1, they also have a story. Let's say originally there are 10 brands, and then they have 10 different color level. And then, so that's a very tricky thing, because when you get one drawing and then you don't know which one it is, and then you have to find a proper brand, which is too difficult, and it's a waste of material. And then, so one brand, which is called Matte, this one brand, they make 221 color. And because this brand is famous for producing beautiful drawings, so that's why after the 221 drawing, 221 color level set up by Matte, all the other brands change their color level to Matte. So that's why now we all use 221 color. But actually, the 221 color they still have drawbacks. For example, this is 16, this is 7. They are very similar, but 6 it's slightly brighter than 7, and then 5, which somehow makes sense. And then, like, if we only look at this, then it's a gradient color. It's fine. We know we want brighter color. We go to a lower level. But the problem is when we look at number 8, it's a random color. So that's and then number 9, it's another random color. So
why is that?
So the tricky thing, yeah. So the way these brands set up color, it's very tricky. I don't think they are following kind of logic. So I hope there's another brand who can take over it. But for now, no.
Yeah, I used to play with these kind of beads when I was very young, but that was probably for kids, so it was much bigger.
Yes. Right. So there are 2 sizes. And this one is 2.6 millimeter, and another one probably you play it's 5 millimeter, which is larger. Yeah. Like normally, I think in Europe in Amazon you can buy 5 millimeter those kind of size beads, but because it's big, so if you want like detail, you need more, and the final piece will be larger. So that's why in China. Currently in China, it's popular because it's 2.6, then you can get enough detail, but with limited size dimensions. Yeah.
It's very interesting. It's a story of how the media kind of limits what you can do, and then it became a generative force that force you to generate more complex algorithms, methods, and even aesthetics. I think the pixel art aesthetics is because we were having technical limitations on our monitors, in the computers, and then in the games, and then it now became a kind of a style, and then people will do it intentionally. Although we probably have better technique to overcome everything, but still people kind of mimic. It's like steampunk or something. Like people have to have this kind of nostalgia or kind of emotion attachment to certain things. It's cute,
right?
And then the truth. I wouldn't say it's very professional, but it is professional.
Yeah, there's like different tools. There are a lot of. I think this kind of thing also like even this. You see the different lens, so that's why if you use a longer one, you can take a color at more beads at the same time. Like one time, you don't have to change it, and then but compared to this, it's very short. You just do a little bit and then change a little bit, just a little bit improve over time.
Do people kind of compete on the speed of? They could check how many beats you have done.
Yeah. Oh, there's no competition yet, but we can host one. But there's another normally they have other skill, like people trying to find out, which is I cannot do it very properly. So after you got a lot of beats, normally what we do is we put one. You have to do this like every time, but somebody just keep this gesture and like this.
Oh.
The reason why is there's gaps between beads, and then there's thickness. So the second beads, they are held by the first bead and only shifted a bit. So they use kind of physical logic to put it.
So you need to like shake your hand?
No, your hand should be static. Yeah, so I for now I didn't successfully use this skill, but the tricky is the bead, how you control the angle of the bead. Let's say at 45 degree a little bit, and then it will slope from the previous bead to down, and then slope. So that's the trick.
And basically you load onto this like all different beads.
Normally
the sequence of certain things, and you just bring them.
Yeah. Yeah, true. That's also a way to do it.
Like you have to have like servants, slave labor to load your content.
Yeah, well, but normally because we have to shape it to become a arrangement. So normally it's just one color one time. So that's it. That's it.
Yeah.
How long have you been working on this material?
This material is not long. It's like 1 or 2 months. Yeah, but because I learned, like my major is architecture, and then I learned computational computational science. So so those kind of pattern shape, like pixel pattern creation, it's long ago. But pixel art, like this kind of material, is just recently.
Yeah, so you made pixel art long before you know this topic.
Yes.
But like, what's your market for those pixel art? Like, what did you make before that?
No, it's so for me, it's the pixel art. Normally, what I do is kind of because I do architecture, and then we have some kind of patterns. Let's say on the floor patterns or wall patterns, or like decoration or ceramic arrangement. Those kinds of different like.
Or could be tiles.
Yes, tiles. Yeah, those kind of. That's how I use it.
Make a design, and the workers will like based on. So basically the same thing.
Yes, it's the same. Yeah, like even for example, those textile, it's if you abstract it, it also can be a pixel art, like because of the grid. And then so those kind of thing. If I'm going to do it, then I just put, let's say, like straight line and a horizontal line and vertical line, and I run it randomly with like random placement with a computer that's like different, like 1, 2, 3 or 2, 3, 4. It's kind of different numbers to put them together, and then they do their iterations, calculations together, and then they get a result. I don't know the result, but I can see it.
And you can choose it.
Yeah, I can choose it. And also it's the funny thing is, okay, so it's more about work. So the client will ask you for, I want more options, I want more like different choice. And then in this way, you can provide 100 choice at once. And okay, let you choose. Yeah, that's the way.
That's the parameter design.
Yes.
It's very, very interesting. And what made you think that using something very professional and to put it into like, what's your vision on this hobby and combining with your professional life?
Honestly, I just, because this is my habit. So it's just because I love it. It's my hobby, and then it's my habit to apply my skill. So I apply my skill to anywhere, either it's like my hobby or my professional career or whatever, any other where. So just my happy to do it.
They have an enormous like a great tool that you can solve a lot of problems.
Yeah, because actually, if you remember, I mentioned about the software because it's limited. Like I cannot change the color. I cannot. If I want to change the label, I have to change the color. Yeah. But the tricky thing, I do know there's some like if I look at my real material, it's different from the software. But because the software is set up, I cannot change. So I just do it myself. I'm not going to use that software. So that's I just take it as a convenience.
Thank you.
Thank you for joining me.